All right. Alrighty. Unfortunately, look at my faces. I'm gonna move my face to here so it doesn't distract me. All right. So unfortunately, this is like my fifth try. So I'm going to make some mistakes, and I apologize for that ahead of time. But this is pull up the assignment real quick. Generating random points in a three-dimensional matrix around four cluster centers using the Rodriguez and Leo's clustering algorithm, assigning each of their points to their respective cluster centers using Google Colaboratory. So first things first, we need to import all the things that we need. So yes, so import, yep, as NP, sweet, from, let's see if how much of this I can get. Plotly dot subplots, good deal. We're going to import so we can make subplots. Look at that, that's fun. We're going to import that one as tile. We're going to make the default on that. Templates. Default. We're going to make that equal to the dark mode. Dark. Boom, shakalaka. Now let's run it to see if we made any mistakes yet. No mistakes yet. Excellent. So the first things we're going to want to do is we're going to, well, yeah, let's come back to this later because we're going to have to do a different section. But the first thing we want to do is create a random set of points. And the points want to be seeded so that every time the code is like actually run, it doesn't create a new set of random points. So yep. Boom. This is good. Add number as in. All right. I don't think I've made a mistake yet, but let's go for it. Okay. And we want to make centers so that there are four clusters now. So and the locations of the clusters doesn't really matter, but you don't want them to be too close together, else it all gets muddied up. So I'm going to make my first one actually all -5s. Then I'm going to make the next one 7 complete. Let's make the next one something random. So let's do -2. And the last one, let's do, it doesn't matter. No, let's not go above our, no. This doesn't matter. Okay. And let's test that. Actually, no. So we've already made a mistake. List indices must be integers. Not 2, 4, oh, I think I just forgot my commas here. Yep, excellent. All right. So we want to then regulate the numbers on the amount of points that each center can have to make sure it's not disproportional. So in being what's pictures? Is there a dot? I can't remember. I don't think so. And it wants to be between just any reasonable number would be fine. And zero. Okay. So P is the list of 4 arrays. So oh sure. I think I forgot a dot there. Nope, not there. Good deal. So P is a list of the 4 different arrays. So let's make a for loop for an integer in the range of the range that we made. Can't tell you how many times I've forgotten that colon. I've also put 2p. I put 1p in it so many times. So location. Nope. Location center is equal to integer. And the scale to 1. The size I want to be equal to 2, 3. Okay. We're going to need to concatenate these, which let's list. It's like the common arrays need to have common dimensions, so it like stacks them. Concatenate. All right, now let's see if it's still correct. Nope, that was the wrong one. All right, what do we do? P, okay, it's gonna say nope. Num ND array. Okay. Object has no attribute to append. Oh, P. Oh, no P. So in append. In. One size. I'm going to pause recording so I can look at this without actually think about it for a minute. All right, I think it might just be because it's not in the same, and we have to define P. No. All right. I'll be back as soon as I'll be back. I honestly don't know why. So I'm actually just going to redo it and hope that that for some reason fixes it. So what we're going to do, we've already imported all of our good things. And I'm actually going to jump up and do something that we're going to have to do later. For when we identify the points with like the largest number of points around by looking at each individual point. And then for every point, we're going to try to find the distance to the closest point with a higher number of points around it. And this we'll jump back to this when we do that. So data. Why do you make the line between them data in position one for one subtracted from the data given zero position. And then we, so the whole point is like determining the length of the vector between 2 points. Just gonna be the line divided by the square root. This Q R. You actually thought I was going to find that for me. Unless I line divided by P dot square root. It's the sum of the line squared. Okay, so looks right. Yeah, I think. Okay. So after we find the baseline and project along the unit line to determine the distance, when you subtract the unit line base from the original vector. Yeah, at least that's so we want the data, normal data, which is going to become data minus normal data. So the vectors can become the normal data subtracted from the line. And I missed this one so many times by not capitalizing the none. I'm going to multiply that by multiply by data. Nope. Heat's expensive, so we keep it cold here. Need a comma there, or else it's not going to understand what I want it to do. All right. The distance between the points. Square root of the sum of the vector of the perpendicular vector, not perpendicular, vector squared nope. All right, and let's get return. Argmax. All right, let's see what mistakes we made. Ooh, that worked the first time. Hasn't done that before. I've always missed at least one thing. So now that we have that set up, we're going to come back to that later. We're going to want to create an array, not an array, create a set of like random points in 3 dimensions. And we want it to be like seeded so that every time we run the program, it doesn't create a new set of random points. It wants to say be the same set of random points. So this is good enough. All right, this is where I messed up before. So let's hope that it actually works this time. So we're going to do centers. So I'm going to make them a little bit more conservative this time, because even though that's not likely to be the reason why. So we're going to make NP array, numpy array. So even though, so we're going to make random points, and we want them to be seed points so they don't change every time we run it. We want them to be around cluster centers. We want them to be around 4 specific cluster centers. Now we are going to set the cluster centers that we want these points to be distributed around. And so this is just creating the data that we're going to then interpret. Anyway, so let's create the centers. So it doesn't really matter as long as they're not like 2 bunched together. So I'm going to make the first one -5s. Can't forget the commas. I did that once too. Next one, let's make it all 3s. Next one, let's make it, mix it up. Next one, let's continue to mix it up. 2, okay. All right, so I'm not going to check this yet. I'm going to get the whole block, so hopefully it doesn't give me the same error where I just could not figure out what the error was. So random integer. Hold up. Thank you. Where was I? Okay, so we created the seed. Okay, we had the array. We had the centers. Okay. Not ONP. Random integer. I think that might be what I missed before. I think I typed out random integers instead of randint. But let's see, it doesn't matter. We just want to make sure when they're not all over the place, because this is going to be creating the field or like the mist of the points. So but we want to keep it within reason. So around each locus, but we want to keep it within a reasonable range, because otherwise we could have disproportionately large locuses. So let's keep it between 25 and 40. And that would be within. Okay. All right. So we're going to want, this is regulating the number of points that any kind of center can have. But the P that we're going to make here is going to be a list of 4 arrays, and we're going to want to concatenate them so that because they're all in the same dimensions, and we want them to like stack on top of each other. So for I in the range we have created, shape, not shaper. And also range, not range. Shape 0, don't forget our colon, I missed that a lot. All right, moment of truth. And MP, random, normal. I should not put spaces because I'm superstitious. Center of and a scale of 1. Oh, we don't need those, I think, with that one. Yeah, I don't think we need those. And then this, but the size we do. This one's 1, which means that this, okay. All right, it's not the same error, at least. It's a different error. Because I really just could not figure out what that last one was. Incorrect syntax. What do we have? I bet you have missed a comma. Yep. Still incorrect syntax. I bet you missed a different comma. All right. I think I need an open parenthesis in front of the array. All right, let's try that. Yes, excellent. I honestly don't know what that error was before, but I'm glad that it fixed itself. So now we need to concatenate these. No, we just did that. No, we still need to do that. We still need to concatenate these. Let's just do it right now. There we go. Concatenate. Concatenate the P. All right. What? All right. Hold up. Give me a second. I honestly have no idea. Like, I don't. I might have to come back to this after doing some more because I literally just don't. I don't know. I'm gonna try just coding it out again because sometimes it's wonky like that. See, literally, like, see, literally, I didn't do any. I didn't do anyway. Doesn't matter. So now we've got that all concatenated. They're all in the same kind of section. So now we need to randomize all the points that we actually made. So it's going to make the index. That's complicated. Let's just make it n IDX random. Random. Nice. See if I can get the whole thing. Dot permutation. Yes, excellent. Is NP dot range. Nope, not capital A. Arrange, nice. And we're going to do P dot shape. Shape, excellent. I like it when it does that. Good deal. The random index, yeah. Yep, random index, the key. Excellent. Now we're going to make a figure. Make subplots. Huh. Nope. Scatter. And let's be three-dimensional with X going to be first. 0. And then Y will be the first, second, which will be 1. And then I hate my face there. I keep getting drawn to my face. Anyway, Z. They want text. Array. NP array. No, it's not array. It's I'm so used to it. Work keyboard. We don't want markers and we want text. Text. Yeah. Okay. I'm actually gonna go ahead and do a column, bring that back. So I like it. Neat. So we got the column already. So color. Marker. Red, green. I don't actually know what that means, but I like to think of it that way. We need 4. 1 for each of the locus, the loci. All right. We want them to be one. Stop it. And finally, so cool. All right. Maybe go over that real quick. So this is going to create a 3D like system, a 3D of observation of our points. I think I need to change the layout. Let's see. All right, invalid syntax. Oh, I need to underscore on scatter. And I actually have to. I'll be right back. Sorry about that. I really had to go to the bathroom very suddenly and urgently. All right, so let me do I think the underscore there. I think that's what I just did. Let's try that. Okay, no. My face. Oh, done. Okay. Oh, forgot to do the y equals p of that, not just y that. That doesn't do anything. Let's see. All right, let's try that. Well, that was definitely a problem, but we're still missing something. Sorry. Just a second. Thank you. All right. Excellent. All right. So we're exploring. Oh, yeah. That boy is not supposed to be there. All right. I've just made all kinds of errors, haven't I? I'm not sure if, well, I mean, I've forgotten a part anyway, the marker line color. Okay. Like that's not gonna fix things though. It's just gonna make things worse. Let's see if I can't figure this out. So fig.add scatter 3D, open parentheses. That should be right. Right. We've got x equals p. All right, comma. Y equals p. The second, and then z, comma, text, edit, p, arrange, p shape. All right, let's bring this down. Just open parentheses. P shape. All right, I think, okay, here we go. That's got to be closed there. All right, I'm going to pause again while I think about this so you're not just watching me think. Okay, I think I have it. I think I have it. What did I just do? Okay, yeah. I thought I had it. Okay. Marker line color equals, marker color equals, marker line width equals, right, mode equals. Okay. We did fix the problem. Now we have a different problem. There's a chance that having it all, nope, okay. No, it's one, okay. So our random index and random interaction. My face keeps distracting me. All right. has no shape. That's the only thing I can think. No, that wasn't it. Okay. That is correct. I did need that extra there. This has no attribute shape. This literally worked. I can't. And this T in text. Let's see if that fixes it. Come on. Yes. All right. Well, that was a lot harder than I anticipated it being. But now we have our points. So this is our random points that we generated on in a 3D plane. We can begin to see a little bit of the loci come into play. I'm only seeing really 3, but we'll have to see. So now we want to analyze these clusters with around these locus, the clusters around the locuses. So we're going to want to find the distance between the points, expanded rows and the columns, and then subtract, so like in the X, Y, and Z plane. And we're going to need to do like a version of the rise over run. So like X, Y, Z, and get the delta between each of those, between each points. So first, let's get started. So some minus. So this is going to be the X. This is going to be the Y. There we go. And then square that. There's my little star. -1. And we're going to square that. Then we're going to square root that because to take the find the distance between those 2 points. I feel like those don't add up. Yeah. There we got some. Okay, we just have a bunch of extra beads, I think. Also, I don't think that matter, but we'll find out. Okay, 1, 2, 1, 2, 3, 4, 3, 2, 1, 0, -1. NPD equals NP sum P noun minus by comma. We don't want 0.5. I mean, we don't want 0.05 and 0.5, but that's going to be a big issue. Yeah. All right. I cannot amend tree. What? I didn't do anything that time. I hate coding. Anyway, all right. So this is to find the distance between the points and expand the rows and columns and subtract the x, y, and z's from each. Kind of like more complex rise over run. But the distance between each point, we want to keep it. Sorry, my brain just fuzzy. All right, so we're going to want to keep it under 5% so it doesn't get completely out of hand. If it gets too large, then it's just going to become very difficult to deal with. So let's do the percentile. NB dot per nice percentile. Indeed. Keep it at 5%. Yes. All right. And then we're going to want to determine the local density of other points, or the frequency. Add up. Give me 1 moment. For some reason, someone's calling me on Teams. Don't know what that was. That was very weird. All right. Okay. Oh yeah, we've got the 5%. Now we're going to where are we at? Okay, we've got the graph. Okay. So got to find the distance. Okay. Why do I have a negative? Is there a reason I had a negative around there? I don't think so. Yeah, I think I was just wrong. Okay. Well, equals NP sum, NP is P negative B. The difference between the axis of 1. Okay. So then we need to find after this. So after we determine the local density, so that's what we're doing. We need to find the closest distance between another point that has a higher density than the original point or point frequency, and then expand the filter again to pull out whichever points meet this parameter. So let's do the original. There we go. Capital. Which is going to be if it's more than the density. So the nearest higher density index is going to be equal to get those dots. Right. All right. So then we need to find the central points with the largest number of the points that are close to it. So max is equal to arrangement max ARG max of row. And then change row max is going to be equal to max did I do? I think I have a space there. Yeah. Did I? Yeah. Yeah, here we go, row max. Yeah, here we go. Okay. All right. Now delta rho is a better indicator of the locus density of a cluster than just the delta. So and let's see. The average. Right. So let's find all right. Let's see. I think that is supposed to be rho, JZ. Okay, it was, but that is not the only problem here. No attribute to local knot. Right. Let's see. It's because there is no local knot. It is logical. Logical knot. That's close. That's better. Name delta is not defined. DLT. All right, because I did not define delta, I defined it delt. All right. Different errors, always good. Meeb, yeah, because that is not a thing. Good deal. All right. Excellent, excellent. So after we do this, we want to create a graph. Oh, we're going to create a graph showing the distance between the points against the sequential values to determine the effective cutoff range. Because if you, oh man, you know what, I shouldn't even bother. Because the distances, I mean, you're going to have a certain range to define what points are in each loci of the loci, and to have them independently designed, not getting in each other's territory, you need to find kind of like the cutoff, and the best way to determine the cutoff point is to graph. So first, let's delta with an actual delta. It's going to be equal to, so we need to find a cutoff point for the delta range. That's what we're doing right now. Sort. Delta. Yeah. And we're going to locate the index. So now we want to locate the index position of the correlation point with the greatest distance to try to help us figure out the number of clusters, which we know is going to be 4, but we don't know that, and the number of focal points for the clusters. So, and that's when we come up to the knee function that we did earlier here. We're going to be using that to determine yours. All right. Yeah. So, no, we're not here yet. So, okay. Yeah, we're trying to determine the space between them. Okay, so we're going to go back to the knee point, the knee, because it looks like a knee. Arrange. Change the size. Change. X, Y, I will find out in a minute, won't we? There we go. So, make subplots. Aha. Nice. I'm not going to add a 3D scatter, just a regular scatter. Okay, arrange. Equal. No, delta height. In the mode we want. Works. No, it's fine. It's fine. All right. I'm sure I've made issues. Oh, one more thing. I want to adjust the actual size, and I'm going to make the width and the height. All right, now let's try to fix our errors. All right. So it's not a problem with this. I mean, there is. The problem with this is that actually we have a problem up top with our knee function. It says that norm is not defined. So I don't think it's supposed to be like that. Let's see if that fixes our problem. No. All right. Perfect is not defined, which makes sense because we did not define perfect. We did, however, define perfector. So let's go up and fix that real quick. Perfect. Perfector. All right, once more with feeling. Okay, let's see, name axis is not defined. Still back up with knee. Okay, let's go back up to knee. Axis. All right. Axis is not defined. I think it's because we just had two equals there. It's not supposed to be like that. So back up to our knee function. Axis equals 1. That is not correct. Let's try once more. All right, that's much better. Although our graph is not supposed to look like that, although it actually might. I feel like it's not, but we're going to keep going and see if just the way the random numbers all fell, they just happen to be like that. Who knows? All right. So we're going to go back. Actually, I'm going to go over it again because that doesn't seem correct to me. I'm going to reduce the height and width and see if that gives us a better picture. Do the opposite and see if it gives us a better picture. So they all seem to be similar, and that feels wrong, but we're going to roll with it, I think. Okay, well, so we'll move on from here for now and then come back to it if everything else is just wonky. So now we need to analyze the clusters and find the difference between the points expanded from the rows and columns, and then just subtract each x, y. No, that's what we just did. That's what we just did. Yeah, okay. I get myself mixed up because you got black screen number 1 and then black screen number 2. Now we're going to work on our third and final black screen. Okay, let me gather my thoughts for a second. So still this doesn't feel right to me. But we'll see. So we already sorted the indices based on the row and delta products from 0 to the number of clusters, which is good. Yeah. Yes. All right. And use the NP arrange to sort so we need to give the assigned indices clusters, like sort them into each of the clusters. So indices. Lost my train of thought. So hold up, maybe green my train. Okay. Okay, which makes sense. So the indices we've already sorted the indices based on the row delta products from 0 to the number of clusters. And so when you assign the indices, to which of the indices have been assigned to which cluster. So that's what we're determining now. So the assigned index is going to be equal to NP where cluster is greater than it's going to be 0. So how many assigned to the number of clusters? So the number of assigned is equal to the assigned index assigned is equal to assign index. Okay, so we need to determine which so after we determine which have not been assigned to a cluster and separate those from the ones that have been assigned to a cluster. One day range. Double change in index. All right. So let's give this a go. Okay. So probably have another. One too many range. Let's see if that fixed it. All right, we'll pause again while I'm checking on. Okay, I think the capital NP is what has done it. Now, oh, we're getting closer. Name in though in cluster has not been defined. Okay, that's because cluster. Okay, so somewhere I have Cool. Moving on. NP arrange. There. Okay. Truth that I have any array with more than one is okay. So I probably have is equal to NP. All right, I'm going to do this. I honestly can't figure out why this is doing. Okay. Oh, okay. That's supposed to be there. All right. Let's see. Excellent. All right. I'm gonna have to do that every single time, which is fine. I'm fine with that. I tried a couple times and I always have the same kind of stuff. So it doesn't make sense to keep trying to redo it without, like, because syntax things are like my biggest thing. So finally, we still need to kind of finish assigning points. So we're going to create a while loop to do that for us. So while the index size is greater than 0, num1. So we're going to make the data index refer to which data point, and the cluster index is going to be the assigned cluster that we're putting that point into. So we're going to need to do another expansion in order to assign the points that do not have a cluster assignment present. So while assigned index is greater than 0, cluster. No, not that part. Normal one. NumPy, non-zero. Nearest, not nearest. Yep, here's how you put the index. Now I'm going to actually scoot down here because I don't like getting too far out. So index cluster here is higher density. Okay. We do not want to include the cluster centers. Capital blue. Capital blue. Boom. I know I'm missing something. Boom. I'm probably missing something else, but we're gonna try this to make sure. Did I give it an end? No, I didn't. So stop that. Args and quarks. Okay. I don't know why I did that. Okay. So we want to make sure that the non-cluster indexes do not include the points that are the centers themselves. So the total number has to be, because we have four centers. So we have 4 centers. The total number is going to be 4 shy of the total number of points that we actually have. So to accomplish this, yeah. So, like noodles. Oh my God. Yeah. That's what we call it. Yeah, right there. Nice. So we need to be careful to match the correct rows and columns. So we need to assign it this. Really? I'm surprised. I'm probably gonna have to come back up here and make adjustments later. It's positive. All right, so now that we've done that, we've assigned all the points. We want to make a 3D visual graph where we can have each of the points that has been assigned a cluster the same color as, like a different color each of them, so we can visualize it a lot easier. All right, so what colors do we want? Blue. Or maybe red. Yeah, let's do red. And let's do orange. Yellow. White. What are we doing? Oh, forgot a column. Yellow, white, and let's do green. All right, so we're going to make a figure, the final figure. We do a 3D scatter this time. Colon first for that, obviously. X is going to be that. Y is going to be equal to, did I put the P in there? Yeah, okay, can't read the P, I did that earlier. 1, and Z is going to be equal to 2. All right. Text. I always do that. It's 1A. Yes. Is it going it? Yeah, good. Cluster, yeah. No. There we go. Cluster. Not colo, text one color is equal to colors. Cluster. Already have. Stop that. Stop that. Here we go. All right, so we've got the node, we've got the color, we need the position. So scatter 3D. Text equals NP. Let's this one. Center. I don't think we need all of these. There we go. Okay. It's going to be errors, but we're just going to keep going. All the errors at once. So this is all just kind of to make our graph look like observably clear. Actually, red, green, and so we've got the marker color, but we need the marker line color. Yep. And then we also need the marker line. Yeah. We want it to be red, or we want it to be, I'm gonna make it blue actually. Align with 1. Align with 1. Vision. Make it middle and center. I think that needs quotes. That's a lot. I really hit myself there. I thought I was doing the third figure. The next figure two thing. So we actually have the first add scatter that deals with the actual points. And we have the second add scatter, which deals with all of the colors. So this is 3D2. Obviously. Y close this. P. There we go. Delta index, column 1. C is going to be equal to P. Index. I'm going to go down because I hate make it too long. No, I think I forgot to add the clusters. Yeah, I did. I forgot to add the clusters. So, oh my God. I think I made a mistake. Yeah. Okay, okay, okay. I forgot to add the clusters in that one in Z. So it's not one that is index. Nope, just go. And Z is the same. We got the marker. Okay. Size 15, middle center. Good deal. And the last issue is we want to make sure that the size is the same as before. So actually remember what I said to before. So let's just make it in the height. And good deal. Now let's start with the issues. Okay. Same as before. Don't. Comma. I hope that's it. We'll see. No, that wasn't it. It's okay though. All right. Found another missing. All right. Where's it? There you are. Okay. I found yet another missing comma. All right, we're getting there. Probably missing another comma somewhere. Comma. Oh, for the sake of clarity, I normally don't like them all. I think for my own visual purposes. It's going to be, why is it going to, okay, I'm not on the screen. It's going to be easier for me to see my mistakes like this. I forgot. This has, aha. No, still syntax, okay. There you are. Hopefully. All right. Not defined. Is not defined. All right, that's because I do fig up here. Fig 2. All right, let's go, let's go, let's go. Figure object has no attribute. That's got a 3D. All right, this one's going to need more thinking also. Because skater is not a thing. Scatter's a thing. Skater is not. All right. Next 35 is out of bounds. 0 and size 5. Could not for the life of me figure out what was wrong with the code. So I just did what I usually do and blank it all out and then redo it all. Yeah, I hope it works this time. I'm gonna go over it one last time. Let's see. Oh. So, syntax. Might have to pause. No, okay. There's another extra comma. Okay. Last time, let's go. Taking a while, that means it's trying to work. Excellent, and there we have it. We're only seeing 3. Oh, there's the 4th right there. Huh. None in that locus, which is weird, but there you have it. Oof, it wasn't super, I mean, always with the syntax errors, but we got there. And that's, yeah, so that's how you do. Excellent, excellent. Thank you very much.